Hello everyone, I'm Brian. In this video, I will teach you about e-science. E-science is a computationally intensive science that is carried out in a distributed environment, or science that uses immense data sets that requires grid computing. To explain this topic, here's Manzon.
What is up guys, this is Ruffled Ken Manzon and my topic is e-science. What is e-science? E-science or e-science is computationally intensive science that is carried out in highly distributed network environments, or science that uses immense data that sets require grid computing. The term sometimes includes technologies that enable distributed collaboration, such as the access grid. The term was created by John Taylor, the Director General of the United Kingdom's Office of Science and Technology in 1999, and was used to describe a large funding initiative starting in November 2000. Electronic science has been more broadly interpreted since then as the application of computer technology to the undertaking of modern scientific investigation, including the preparation, experimentation, data collection, results dissemination, and long-term storage and accessibility of all materials generated through the scientific process. These may include data modeling and analysis, electronic or digitized laboratory notebooks, raw and fitted datasets, manuscript production, and draft versions, preprints, and print and or electronic publications. In 2014, IEEE, or Integrated Electrical and Electronic Engineers, e-Science Conference Series condensed the definition to e-science promotes innovation in collaborative, computationally, or data-intensive research across all disciplines throughout the research lifecycle. In one of the working definitions used by the organizers, e-science encompasses what is often referred as to big data has revolutionized science. The Large Hadron Collider, or LHC, at CERN generates around 780 terabytes per year. Highly data-intensive modern fields of science that generate large amounts of e-science data include computational biology, bioinformatics, genomics, and the human digital footprints for the social sciences. Electronic science revolutionizes both fundamental legs of the scientific method, empirical research, especially through digital big data, and scientific theory, especially through computer simulation model building. These ideas were reflected by the White House's Office on Science Technology Policy in February 2013, which stated many of the aforementioned e-signed output products for preservation and access requirements under the Memorandum's Directive. Electronic sciences include particle physics, earth sciences, and social simulations. Most of the research activities into e-science have focused on the development of new computational tools and infrastructures to support scientific discovery. Due to the complexity of the software and the back infrastructural requirements, e-science projects usually involve large teams managed and developed by research laboratories, large universities, or governments. Currently, there is a large focus in e-science in the United Kingdom, where the UK e-science program provides significant funding. In Europe, the development of computing capabilities to support the CERN Large Hadron Collider has led to the development of e-science and grid infrastructures which are also used by the disciplines. And that's it. Thank you for watching.
Let's move on to another topic. Computational science. Computational science is a rapidly growing multidisciplinary field that uses advanced computing capabilities to understand and solve complex problems. For more information about computational science, here's Cueva.
What is computational science? What does computational science mean? And what computational science meaning? Computational science is a rapidly growing multidisciplinary field that uses advanced computing capabilities to understand and solve complex problems. It is an area of science which spans many disciplines, but at its core, it involves the development of models and simulations to understand natural systems. Computer science is considered as part of a family of 5 separate yet interrelated disciplines. Computer engineering. Computer engineering is a branch of engineering that integrates several fields of computer science and electronic engineering required to develop computer hardware and software. Computer science. Computer science is the study of processes that interact with data and that can be represented as data in the form of program. It enables the use of algorithms to manipulate, store, and communicate digital information. Information system. An information
For bonus content, here's Perez to help us distinguish about digitalization.
How does digitalization help us to understand society? Digital transformation, understanding the impact of digitalization on society in the face of few societal challenges. How can digital transformation make a positive contribution? Digital transformation is generating a fierce debate among policymakers, economists, and industry leaders about its societal impact. As digitalization disrupts society even more profoundly, concern is growing about how it is affecting issues such as jobs, wages, inequality, health, resource efficiency, and security. To help begin a new evidence-based debate on the future impact of digital transformation, we have conducted a detailed quantitative analysis of the value at stake from the digitalization of 11 major industries. In each case, we have calculated projections of the potential value of digitalization to the industry itself and emerging sources of value for wider society, as measured by an intentionally narrow set of indicators. Over time, this approach may be broadened and refined. Pre-cut mo na lang ah. Wait lang. Yun. Ito na. 1, 2, 3. So, how can digital transformation make a positive contribution to society? We have focused on 3 key areas. Employment and skills. Current estimates of global job losses due to digitalization range from 2 million to 2 billion by 2030. There is great uncertainty with concerns also about its impact on wages and working conditions. Environmental sustainability. The historic trends hold that for every 1% increase in global GDP, CO2 emissions have risen by approximately 0.5% and resource intensity by 0.4%. Current business practice will contribute to a global gap of 8 billion tons between the supply and demand of natural resources by 2030, translating to $4.5 trillion of lost economic growth by 2030. Number 3 is the trust. Social media radio frequency identification or RFID tags and user-generated websites such as TripAdvisor have been instrumental in increasing transparency and overcoming information asymmetries. However, according to the Edelman Trust Barometer, Trust in all technology-based sectors declined in 2015. With concerns over data privacy and security a key factor, broader ethical questions about the way organizations use digital technology also threaten to erode trust in those institutions.
You so fucking precious when you smile. Hit it from the back and drive you wild.
Click here.
Click here!
Click here!
Click here to subscribe.